Hi, I'm going to be talking to you today about IsoVis. IsoVis is an educational tool that I developed for the web browser. It allows you to visualize high-dimensional functions and specify your own and interact with them. I'm going to be talking about the big idea, how it works, showing you how to use it, and what all these different buttons and sliders and everything mean. Now this is just running in the web browser. It works best in Google Chrome. I'm going to full screen it. Now this function is defined in a specific way that I'll go into a bit later, but it takes in this case, 5-dimensional value. You can adjust this to however many dimensions you want, and it outputs a single real valued number. And then I run an algorithm called marching cubes, which is going to generate this this geometry that you see here that visualizes where it crosses this certain boundary value, which I call the ISO level. And yeah, let's go through and start talking about what all the buttons and sliders do. First and foremost, if your computer ever starts to lock up, I mean, it shouldn't happen, but if it does, just click abort, and it will go back down to using very little memory. It'll drop the resolution to 10. It'll kill off all the parallel processes running in the background, and it should help if you ever have a performance issue. That said, you probably shouldn't. Modern computers should be able to handle this just fine, as long as you have a reasonable GPU to be able to handle the WebGL that's being used to power this. So over here, these are some of the easiest to explain things. So I'm going to start with this. We can change how much of the screen real estate is provided to the editor. So that's pretty straightforward. We can adjust the resolution, which is the size of the denseness that I'm going to be sampling this function, the density that I'm going to be using to sample this function. All the way up at 65, it's probably going to use over a gigabyte of RAM, which shouldn't be an issue on modern computers, but just be aware if you have a really old computer, you might want to keep this to a smaller value. Plus, it'll be much more responsive. So if you double the resolution, you're making your computer do 8 times more work and making it store 8 times more stuff. The interpolate is actually kind of broken right now, but that's okay because it's broken in the on position. And what that does is it kind of smooths out the mesh. It interpolates each one of the vertices here between the sampled points. And that just gives a much better user experience, I feel. And it has a very little overhead, so that's not an issue. Memory overuse is just for a technical reason, shouldn't bother you whatsoever. If you were on a really old computer, try dropping this all the way down, or leaving it to a quite small value before you start experimenting. Let's see, so the ISO value is what surface I'm visualizing. So here I've defined some function, we'll go into that later, and I want to find all the places where it crosses the 5 value. So this is showing the boundary between less than 5 and greater than 5. That's it. I can change the number of dimensions. When you write your function, you're going to have to assume that you have a certain number of dimensions, and if you set this value too small, you will have a bad time. Things will mess up like this. This is not how it's supposed to look. But if you set the value too large, everything will still work fine. So if I set this to 30 for some reason, it works just fine. Now, you can supply certain coefficients to your function. These are just constants that are going to be supplied to your function that you can tweak. So here I have the cross product, the Cartesian product of a couple of toruses, and I can adjust these values here. So this, I've said that I want 6 of them, and that is stored in the array C over here. Now this is just JavaScript. So the first value is indexed with 0, and it is 3. So I can change this up to 14.4, and now it's subtracting 14.4 from the t variable in here. And I can do this for as many coefficients as I want. I think actually I put in an artificial limit, but that's just to keep you from accidentally adding such a huge number that it causes a problem. Again, there's no reason not to have more coefficients than you actually need, but if you have less, it can cause problems. So, yeah. I'm actually going to refresh the browser window to get me back to the original settings. Okay, and increase the resolution a bit. Let's see. So I can click here to expand and collapse different things in my controls. And if we go into camera, we can shift between having a perspective or orthographic projection mode. Just a side note, kind of embarrassing bug, but the aspect ratio here is actually kind of linked to your the aspect ratio of your monitor. So until I fix that, this is going to look a little distorted, but that should be a really easy fix once I get around to it. So this is an orthographic projection, so things that are far away look the same as things that are up close. I feel that it's best to leave perspective on, especially because of this gentle rocking motion that I've added here. It helps your eye, really see what's in the foreground and what's in the background. You can adjust the field of view, and I feel that the default is pretty reasonable. So the next two values, the radius and the speed, are just controlling this gentle bob that I've added in. That's kind of automatically showing you the 3D structure by rotating it. And you can adjust how fast that's doing it, and the size of the rotation, and stuff like that. Pretty straightforward. You can turn the axes on and off. You can adjust the background color. And if the interface bugs like this, one of the tricks is that you can click here, and now you have more room to play around with. Okay, so I'm going to leave it on kind of a dark blue. There's an FPS counter down here and a latency counter. You can turn that off or on. Now, let's see. Many things in the material tab are actually broken. I just started adding things to see how it would react, and it's not really a priority for me. I'm working on porting this to VR, virtual reality headset. So I feel like this is a pretty reasonable default. That said, you probably do want to change the opacity level if you're going to have really different levels of mesh densities. And you can change the material a little bit. Wireframe is the only mode that works right now. So you can, and calc normals is forced on in order to be able to visualize this. I feel like the normals material works the best. That just shows you the direction. So it looks like everything here is colored based off of its location in space. It's not actually true. It's based off of its orientation. So, and you can change how it's blended, which will just give you slightly different visual effects. And some of them work better than others, especially the ones that seem really dark work better against a light background. The side doesn't matter because it's stuck on wireframe mode right now. We can, however, go to custom that allows you to change the equation down here. And these are just built-in materials that came with 3JS, the library that I'm using to create all this. So that's different ways of blending the colors together. That said, you don't have to worry about most of this. I'm going to refresh again to get back to the defaults. Okay. So let's say I wanted to zoom in. I can just click and drag this. Interesting to note that this is a constant variable zoom, so this is not super easy to use. It's not super human friendly, because here, once you get down to very small values, it becomes very sensitive. But at large values, it's quite insensitive when I move the mouse the same amount. That's actually, I might put up a video later kind of showing you how to fix that in the console. It's very, very easy fix to make, to switch to some sort of exponential or logarithmic style control. But I just thought it would be neat to show beginners how to actually interact and touch software like this through the development console, which I'll pull up now. So you can actually go in here and type in code down here at the bottom that is going to be able to affect and change how this piece of software works. And I think that's a really neat thing for beginners to see. Okay, so the big idea, the most important thing that's going on, is how you are visualizing a higher dimensional space. What I do is I sample a 3D cube of points, so roughly, I think this is positive 10 to negative 10 on each axis, with some density. And this is, I think, per octant, so in this case it would be like 36 per each one of these eighths of this cube, by 36 by 36. And then I'm going to apply some linear transformation to it. If you've not heard that word before, it means I'm going to generate a new coordinate based off of multiplying all the previous coordinates by some value and adding it up. It's multiplying a matrix by the vector that represents your position in space. So initially, my position in space for, say, this point over here is 0, 0, 1, 0, 0, because I've got 5 dimensions. And this is the third dimension over here, the z dimension. Let's see. And so I can apply different types of linear transformations in a stack, one after the other. And I only have support for 4 right now, but this is actually enough to generate any other type of matrix, any type of linear transformation that you might want. So if I go in here and I change, this is applying a single rotation between the first dimension and the fourth dimension. You'll notice that things are indexed by 0. So 0, 1, 2 is actually the first, second, and third dimension, the x, y, z. One of the easiest, so this is rotating the x dimension through the fourth dimension by 24 degrees. I can turn this off by either specifying 0 degrees, or I can turn it off by changing the two axes to be the same. It's smart enough to know that that means don't do anything. Or I can pop the entire transform entirely, so now it's gone. It's not there anymore. So let's push a new transform to the top of the stack and show how this works in just using the basic 3 dimensions. So let's say I wanted to rotate something through the x and z. I wanted to rotate this around the up axis on the horizontal plane. So I'm going to select these 2 dimensions, that's the x and z, 0 and 2, and I'm just going to drag the degrees over. So it's important to note that I'm actually applying the inverse of this operation in order to make to the points in order to make it look like the shape itself is rotating instead of the points that I'm sampling. And that's true for all the linear transformations I have. So I'm going to rotate it by 90 degrees, just exactly 90 degrees. Okay, and it shows you what it looks like. And of course, because it's naturally circularly symmetric along the y and x dimension, just because of how I've defined this function here, rotating between these two doesn't appear to do anything. The operation is still being applied, it just happens that the function is circularly symmetric, so you don't see it. Okay. Now, things get interesting when you combine operations. So I'm going to push another transform, so now I have two rotations. Okay, so the first one's still up here, and now I'm going to go ahead and apply a rotation between the x and y axis. And this time you see, of course, it does actually rotate on the xy plane, which is to say around the z-axis. But if I was to invert the order of operations here, so I'm just going to rotate this, say, 45 degrees. I was going to go into these transforms and invert the order. You see, I don't have the same result. And that is to say that these operations do not commute. So if you change their order, you get different results. So you can permanently apply some of these rotations by clicking Apply Transforms. That will apply the entire stack of linear transforms to your object and create a new default representation in space. That's probably not useful for most people. It just looks confusing. So if I uninvert the order and I apply the transforms, I'm going to remove all the transforms when I click Apply. Or, interesting. That must be broken. That's actually a good thing, because that is probably more confusing than is actually necessary. I can reset the orientation by clicking down here, or I guess that's also broken. Neat. I can just pop all the transforms quite easily by clicking this button. That's just going to get you back to your defaults. What appears on the x dimension is actually just along the x-axis without any transformations applied to it. Okay, and so rotations are not the only thing I can do. So I'm going to rotate this a little bit. Just give it off axis so I can really show some of the effects of what I'm about to do. Okay, so now I've got two rotations. Now I'm going to scale. So I can scale things along the x-axis, like that, make it stretch it out, and if I scale it by a negative amount, I'm actually going to be flipping the space, inverting it. And the same thing happens if I zoom to a negative amount. I guess I have clamped that. But if you go into the console and you change the zoom to a negative amount, it will actually turn the whole space inside out. It's pretty neat. So here I am applying it to each scale along each axis. I can do this to multiple axes at once to kind of simulate a zoom effect. If I wanted to, if I set this to the same everywhere. But what's interesting is here, scaling along the third dimension, the axis 3, the fourth dimension, doesn't appear to have any effect. So I'm going to pop that transform, push a new one. But if I go in here and I rotate to the a little bit to the fourth dimension to kind of change its shape a little. And then push yet another rotation and scale the third dimension. We're going to see nothing seems to happen. But what happens if I instead scale the third dimension? I keep saying third dimension, I mean dimension number 3. I know it's confusing, but if you're looking at this from a programmer's point of view, it makes a lot of sense, trust me. So I'm scaling along the fourth dimension, and then I'm going to rotate into that fourth dimension. And you see that we're getting some things that we haven't quite seen before. This looks almost like a tube, so I'm going to zoom out. You'll see there's some tearing here on the side where things are connected where they shouldn't quite be. One of the things you can do to address this is to increase the resolution. And that is because it is scaling the third dimension before it's rotating into it. But if I was applying these two transformations in the opposite order, nothing would happen. And if I invert the entire stack, we get something that looks quite different. Okay, so I'm going to go through and pop these last two transforms, so I just have this initial rotated set of toruses thing, and we'll talk about translation. It's pretty much exactly what it looks like. And again, these are all applying the inverse operation. So if you are wanting to move it, this object along the x dimension by 3 units, what you actually have to do is move the space backwards by 3. So if you ever go into the code, just be aware that's what why that's there. Alternatively, I can shear along certain dimensions. So the matrix is defined as a dense n by n matrix with 1s along the main diagonal, and n is the number of dimensions. So I can change a certain row and column to be any value I want. And that can have some pretty weird effects. But ultimately, it is necessary in order to be able to construct any arbitrary linear transformation. So this is kind of like squeezing the space between the 0 and 2 dimensions. Okay, so how do you make your own functions and how do you edit stuff in here? I'm going to reset back to defaults. Okay, so you have to use this interface over here. The first and last lines you can't edit, so I'm typing here and nothing's happening. That's just to try and reinforce what IsoVis is providing to you. It is, you are defining a function called field, which takes in a flat array, one big one-dimensional array of positions in space. A set of coefficients, C, which is defined here, all these coefficients. The size, the number of points in the space that you're going to be solving for, and the number of dimensions. So we don't have to care about the logic for this loop. And we're going to store everything inside of values. This values array. So the way that this works is that x is laid out such that the very first element of it is the first dimension of the first point in space. Then the second element is the second dimension of the first point in space, and so on. Then after you've done the nth plus one element, right? So after the sixth element is the x dimension, the first dimension of the second point in space. What this means in practical terms is that if you wanted to delete all this and create something from scratch, if you wanted to write something into values, actually, if you wanted to write, just define a sphere, a very simple sphere, what you could do is you could take in, you need to square each dimension. So we go t is equal to t plus one. Okay, I'm going to click update to update what I've written here and show it in the visualization. This is just a cylinder. Notice it doesn't look like a perfect cylinder because of the bug I told you about, or the aspect ratio is wrong. But mathematically it is a cylinder. That's because I have squared the first dimension and the second dimension, dimension 0 and dimension 1. And then I've written that value to values. I've squared them and then I've summed them. And if I did this for all three dimensions, I can use the shorthand here, plus equal. I'm going to get a sphere. And if I change this ISO level, I can get a sphere of different sizes. Now, let's say I wanted to make it wriggle in space. I wanted to add some component along the y dimension that I could control with one of these coefficients. Well, maybe I have an extra variable called u for that. And I can go in and say u is equal to a sine function of first thing in space, and I'm going to output the sum of this sphere and u. So you notice that it's become a little squat, a little oddly shaped. It becomes more pronounced as I increase this ISO level, but I want to be able to control it with one of these coefficients. So I'm going to multiply this magnitude by the first coefficient, and then I can drag this coefficient here and change things. I can also go in and adjust the phase by using another coefficient. And let's see, I can really do whatever I want. The trick here is that I have to write into values. Inside of this loop, I have to write into values indexed by I. You just leave that alone. Some function that is defined by x and c arrays. And when you index into x, you just add j to whatever dimension you want to access, if it's dimension 0, dimension 1, dimension 2. And you just index plainly into c. And that's it. That's the only trick. to reset this. You'll notice that I've changed the ISO level so much, and I've changed the coefficients that nothing's available, that nothing is displayed. So I'm going to drop the ISO level back down and change these coefficients back to values that are a bit closer to what I usually have. And then yeah, that's just about it. You can take a screenshot quite easily. Just press the screenshot button and it will save it to your default downloads directory. There's even capability built in for automatically creating GIFs, but you have to go in and write a tiny bit of code and edit it. You can't run this in the online demo. You would need to either edit things directly in the console or have a version of IsoVis downloaded and edit that yourself. Now the export and import buttons actually will take all the settings, not the function that you've defined, but everything else. So the shape, the position, the transforms, everything. It'll export it to this JSON, which you can then just copy. And I'm going to refresh. And if I wanted to go back to those settings, I can just click import, paste it, and hit OK. So that allows you to share settings with your friends if you had created something that was interesting that you wanted to show them as well. You would also have to send them the function if you had edited the function. There's no specific reason why I chose this one. I just thought that it looked neat. And yeah, if you go and rotate into other dimensions, you can get some weird behaviors. So by defining your own So by defining your own functions, you can get some weird behaviors that you were probably not expecting. Okay, and that's pretty much it. I'm very interested to hear and see what you guys can create. If you have a specific use case for this software or something like it, please let me know. I'm interested in adding new features that could benefit people. And I really definitely would like to hear if you ever use this in an educational setting, or if it helps you in some way. All the code is available online. It's open source. There's a couple of nasty things in the code, but I am available via email. I'm going to have my GitHub link below, so please feel free to shoot me an email if you have any questions. Yeah, thanks for listening, everybody. I appreciate it.